commercial barriers, and then wrapping up with Bradley will pick up the open forum at the end. So yeah, just to note, this webinar will be recorded. At least that slide's got one purpose, and that's deliberate. We want to make this stuff live offline. It's the start of the process. So we'll make the slides available. I think we have a YouTube channel now as well. So the recordings will be there very shortly. And also I mentioned Piranha, our online portal, which is progressing nicely. Firstly, though, for those, apologies if you've heard it almost as many times as I've presented about Celtic Sea Power. We're quite an odd fish. For those not aware, we are essentially a strategic regional development agency under the Cornwall Council. So we're wholly owned subsidiary of Cornwall Council, and we were set up a couple of years ago with a specific aim of maximising social and economic benefit to Cornwall, but also the wider region and the UK. You know, it'll work a lot better for Cornwall if it works well for Wales and North East Scotland and Scotland too. There's also another streamlining flow development, removing, accelerating things through work on the consenting, and various other bits and bobs. But this thread is about strategic sector development, and I'll read this bit because it's the small print. So apologies for the if I go slightly stiff, but. This project will use the data, knowledge, capability, collaboration, and experience gained by Celtic Sea Power and the offshore renewable energy catapult over the last 2 years to drive Cornwall and Scilly readiness to maximise the benefits of a once-in-a-generation levelling up opportunity of a £19 billion floating offshore wind industry on its doorstep. The key outcome of this work will be the Cornwall Flow Commission. Anyone looking at the details of the statement yesterday might have picked that one up. An independent board with convening capability. So project activities will cover key strategic elements, including infrastructure, ports, grid, streamlining regional consenting, catalyse private sector capacity, workforce development, and the outcomes will underpin future work by the Commission. And it's been made possible by shared prosperity level up from the UK government, Cornwall Council, and the Council of the Isles of Scilly. Apologies, I feel like that got at the end of the advert that rattles through it. Essentially, for those familiar, it is a pretty direct continuation of work under complete under Cornwall Flow Acceleration, CFA, but it really moves things on to how are we actually going to deliver this? How are we going to scale up to do this and do it well for the region? I've got some wonky slides here. Apologies. So the objectives of this particular work program, for which I'm the lead, but working with Catapult and I know our colleagues here at CSP, is to catalyse private sector capacity. So what we're really looking to do is, that sector which really well represented on this call, I can see, what partnerships and consortiums do we need to bring into being to kind of make the best of the capability that exists. What inward investment would be useful from the public sector point of view, the de-risking interventions as well. What can we do? What obstacles do we need to clear away to maximise our chances of delivering floating offshore wind with a good, strong impact positively on the region. So through that, we've essentially identified key market segments. There's a Cornwall focus, but we're very alert to developments in Wales, the wider southwest, and the UK, and not, obviously not nearness of the global context too. This flow is a global market, but those are essentially these ones here. So concrete, which we covered last time. Operator maintenance, which is now slipped, hence my old slides here. I might have to go offline and just double check I've got yours online, Charlotte. Inter-array cables, which is the focus of today, anchoring and mooring, O&M, and as I mentioned, cross-cutting products and services, which will capture marine ops vessels. We might delay that one a bit. We're struggling to fully get our heads around. It's a little bit of a sort of loose arrangement of capabilities. So just to mention the Celtic Sea cluster, I'm thrown because I've managed to, in my slight panic, I managed to draw up the wrong slides, but I know the Catapult ones are later. To be assured, I can always change for tack. This the scale of these things. For those unaware, we're looking at around, I think 260 is the latest number, platforms that will be big enough to, football-sized platforms that will be able to hold up a turbine around about the size of the Shard. I always think of being on the South Bank and looking at the London Eye and the skyscraper around there to get a scale of that challenge. Essentially, the numbers that kind of come through, these are as best we can understand it, is about one installed turbine every 10 days for 6 years, 2030. So that's the impact on port capacity, impact on infrastructure, roads and workforce is going to be huge. And so it needs to be regional effort. And at this point, the public sector is reigning with under Celtic Sea cluster, led by the Welsh government has been absolutely key to this. Catapult, ourselves, the Cornwall LEP, and also Minergia Wales have been key parts of that. That'll be in the near future. So as more local authorities on get on board, and this is the pipeline. This is what we're facing. Just to mention the cluster website as well for supply chain covered unaware. It's a fantastic arrangement of resource on there. So these webinars are really a stepping stone to that. Not aware that there's all kinds of reports and on both the cluster and the Catapult. This is the flow pipeline. This is updated fairly regularly. I'm usually caught out with maps, but I think that's the latest from a couple of months ago. You might also have seen, it's 1 minute on LinkedIn, it's a big crisis about AR5, the next minute it's all okay again. It is quite a tumultuous journey. It's very, I think the queue is led by developers who are understandably anxious about pipeline and investment, and the government, which is, can be a little bit opaque in its communications. But really keeping eyes on these bigger numbers to in the longer haul, from a scaling up point of view, from a regional point of view, from I think the UK supply chain point of view, it's the 4.5 gigawatts by 2035, the 24 gigawatts beyond that and beyond, because plenty of wind beyond that really catches the eye. There will be road bumps, but we're looking good for a gigawatt by around about 2031 with the test and demo sites. Hexagon's Twin Hub, I think I might have seen Ben online actually, Rob rather online earlier. But that's reaching a kind of key milestone soon, and we hope we'll be in the water in 2026, 2027. You may correct me if you're online. Erebus was the one that we were expecting to see in AR5, but wasn't. So that's 100 megawatts, which has a question mark on it now. But probably joining the pack with AR6 with flotation, Flaventis, and the Valros project as well. So a little bit of a road bump there, but it's a road bump. It's a setback rather than a showstopper. So this presents some challenges, and it's a sort of laundry list, a long laundry list of things that need to be done, and it tends to be from the perspective of what the industry needs and requires and wants, and it's sort of how high, jump how high kind of situation, which is challenging. And Preston elsewhere has shown that it's really hard to manage. So there's no shortage of challenges, but I tend to sort of think, well, what do we, best do this? What do we have to take on? Which of these elements are going to be regionally bound? So operations maintenance, for example, is likely to need, the geographic determinant there to where it's going to land at Norfolk Haven and Cornwall, for example. There's all sorts of things we have to do. Ports and grids are the first instance, but those cables anchoring the mooring, yes, they're challenges, but it presents an opportunity. We have to see this we have to flip this as an opportunity. What do we want to take on? What can we invest in now? Get the upfront investment into now. Really start scaling up to take on and run with. So flipping that, I love that slide. It makes me happy in a very childish way. Opportunities. Now, again, we don't need to. We obviously dive into detail to some extent in this webinar, but it's not really so much about the details. That's offline. That exists, and the Catapult are brilliant at that. But it's really asking the question: where can we build from strengths? There's export potential here. So, if we build a strength in, for example, inter-array cables in Cornwall or Wales or just the UK generally, if we build that strength. Flow is a global market. There's expertise there that we could very well take to America, South Korea, and elsewhere. So that's a really key element. If we build from strength with no regret activity, that's the phrase that keeps coming around. Maybe the stepping stone projects in the Celtic Sea, they may not be as important to us as it might feel now when we look back on this in 10, 15, 20 years time. So there's real potential here for capable UK companies. And that capability and capacity is my slides are all model. It's really, I did a run through 5-10 minutes ago and then changed slides. So I'm slightly off the pace. Is key. So I'll come back to capability capacity. But essentially the way we look at it is that look, this 4.5, this is the utopian dream, 4.5 gigawatts of flow by 2035. These are the key market segments we've identified, and cables are the one we focus on here. We kind of agree with that. That's what we're aiming for. There's a question of how that pops up, and that's the sort of argument that we go to these offshore wind conferences, we go in a bit of a loop. You know, the way I'd express it is, I think it's a Barack Obama quote, which I'd love to dig out about his time in the White House. It's, you know, we're really good at articulating the problem, you know, and hats off to the catapult on this, you know, getting the detail and understanding what the challenges are. That's the easy bit, you know, that's, you know, it's not easy, but that can be done, and we can look at that in various ways. The tricky bit is, how do we actually come up with a solution? How do we take those challenges away? So our approach now is to say, okay, well, we've done enough talking about this. We need to ask the supply chain. We need to go to the supply chain and present this as a large challenge in the round. The biggest barrier there, and we're going to come to barriers, is, as many of you will be, you know, potentially howling. I've had a few messages already before this webinar. Is purchase order. You know, we don't know who the client is, let alone have a purchase order. How can we start to scale up? How can we prepare for this opportunity, which may feel very abstract for many smaller companies? So, you know, the way we look at it is that capability is there, but it may be sort of fragmented into, you know, smaller fish and bigger fish, and it's not cohering together necessarily as it does, you know, for example, by the tier ones, tier twos from the continent. So our approach is to ask you guys, and this is the starting gun on that. We want to ask supply chain who has that capability, and in that process potentially form consortia to take on those big challenges. The PO challenge and the balance sheet challenge, we're acutely aware of that, needs to overcome the technical challenge, the commercial barriers there. So through this process, next year and a half or so, we want to try and clear away those challenges and barriers as the private sector sees them. Where we can help, we will do our best. You know, what would investment mechanism? There's one of the details out yesterday was on the Crown Estate, trying to make things to clear away for investment there, and interventions, which maybe are down to a local planning level on economic planning. And what can we do to really make the best of this opportunity? And through that, the intention is to kickstart delivery. On the left here, you'll see the webinars here. The Piranha online platform is what we're developing, in which what we hope is that after the webinars such as this, we can corral the good intentions. The companies who really want to engage can then have a forum, a means to do so, and really kind of work together to build this. And those commissions, as I mentioned, will be commissioned in the studies will be commissioned early 2024, and that's direct appeal to private sectors, form consortia, and tell us how will we address this, how will we deliver 4.5 gigawatts with this is the underpinning thing, positive impact on Cornwall, the UK. And that is the underlying driver here. That's what we're nakedly here for. Our own is clear on that, is that how do we deliver all that and also drive economic, social, environmental benefits to people that live here. So a quick note on capability capacity. Essentially capabilities, we've got it. You know, the UK is really strong capability, especially in through cables, like from the experts. I'm sure there are gaps, of course, but it's that capacity. How are we going to scale up and take on these big projects? It asks questions of insurance, which I think Charlotte and Brad will touch upon. It asks a question of appetite for risk, and also getting that inward investment in, that upfront investment in sooner rather than later. Quick slide there, just a nod really to existing materials I mentioned already, but the life cycle overview for the catapult is a fantastic resource being initiated. And once you're in that world, you know, you can kiss your day goodbye. There's loads of good stuff in there if you're not already familiar with it. I've got the wrong slideshow, so just bear with me while I change slides. For those that were on the concrete one, that was been a very, hopefully that was an amusing, poor facsimile of what I delivered before. Bear with me. Talking with yourself for a minute. I'm going to blame Brad for his pre-warm-up chat. Here we go.
If anybody's got any questions, please just sort of put them in the chat, and then we'll address them towards the end, or otherwise afterwards if you've got any questions for us. Thank you.
There we go. Well, I'll just dwell on that slide. Here we go. Apologies for that slight hiccup. I don't think I'm in line to do BBC Spotlight anytime soon. Just in future webinars, we are changing the dates a little bit, so we're holding to these dates now. So we're here today. We've got one next week on A&M, O&M to follow, and the cross-cutting products and services. We'll try and run it in December if we can, but there's quite a lot going on there, so we might have to look back a little bit. If I just flick through. Yeah, just to mention the ITT, that was it. So what we're looking for, I think I said it already, but we're looking for reports, which is to say we really want to, almost see it as a proposal in itself. How would you propose to take on inter-array cables for 4.5 gigawatts of flow in the Celtic Sea, and the underpinning drivers and demonstrating positive impacts on Cornwall and the UK? Obviously, it has to be technically credible, it has to be investable. We're not going to ask companies to share their secrets. If you've got plans already, that's not the intention. We don't want to, but it's to really understand how it can be done. And so that will hopefully guide the developers who are looking to put their bids in, and so we can really raise a flag for the capability and capacity that already exists. So I think I can take a breather and bang on 20 minutes. Hang on to Charlotte.
Yeah, that's great. Thanks, Phil. So today I'd like to kick off by introducing the Offshore Renewable Energy Catapult, and then provide an overview of technical challenges and commercial barriers for inter-array cables. Phil, can you jump to the next slide? Thank you. So the Offshore Renewable Energy Catapult has over 300 engineering, research and sector experts working across world-leading test and demonstration facilities. We have facilities in several locations, including our test and demonstration facilities across Blyth, Aberdeen and Fife. Phil, you can jump to the next one. Thank you. So the ORE Catapult has 4 main technology priority areas, which cables fits quite nicely across most of them. So these are next generation technologies, UK research and supply chain growth. We have energy system integration, looking at demonstration and testing facilities. We have floating offshore wind deployment, which is commercialization of floating offshore wind, focusing on dynamic cables, and smart and sustainable O&M, test and development support and O&M collaboration. Next slide, please. So I'd like to talk you through a little bit about some of our facilities. So we have our high voltage and cable testing facilities, specialist services based on market need across our high voltage and material test facilities, as well as management of test programs on behalf of clients and partners. Our research and testing capability and partnerships in place are to support innovative projects. So we do this through utilising our in-house researchers and academic partnerships in collaboration with leading universities. Our labs are UCAS accredited, covering a number of critical components such as your cables, bushings, insulating materials, generator windings and transformers. And our high voltage labs in Blyth include failure investigations and lifetime assessment. This includes load cycling, accelerated aging, both 500 Hz and 50 Hz, impulse testing, and our material labs for material analysis, including water tree characterization. We also now have in Blyth our new mechanical testing lab for tensile bending and handling. So if that's of interest, please do reach out to myself and Bradley. Next slide, please. So we also have now our innovation centre based in the energy transition zone on the outskirts of Aberdeen. Another testing and demonstration facility supporting the development and qualification of critical components, currently these critical components being the dynamic cable system and mooring and anchoring systems. The aim of our centre is to reduce risk and cost associated with critical components in advance of deployment in large-scale projects. We aim to provide technology developers with access to testing and demonstration infrastructure critical to the development and qualification of technology. Next slide, please, Phil. So this is one example of some of our rigs. So this one is of our new dynamic cable flex fatigue rig with capability of samples between 5 meters to 25 meter lengths. We're able to work with samples between 50 to 500 millimeter diameter. It has the ability to test samples with a bend stiffener attached as well, and a maximum frequency during operation of 1 cycle per 6 seconds. This will be commissioned by early 2024 with ongoing discussions with industry to create a pipeline for commercial work towards 132 kV system qualification. Next slide, please, Phil. So for those of you on the call who are perhaps new to intra-array cables, I wanted to set the scene. So intra-array cables for both fixed and floating wind farms are AC three-phase cables connected in circuits that can be in loops or individual strings, making up your collector grid. Intra-array cables can cost up to £35 million for a 1 gigawatt fixed wind farm, and these costs will rise when looking to floating offshore wind farms. The industry started with large-scale farms using 33 kV. We're now seeing 66 kV as our go-to level, but we'll be seeing it in the future in the current pipeline for qualification of 132 kV as well. All cable systems require protection. Dynamic cable protection will be different from static cable protection, but all protection is used to protect cables at vulnerable locations. So this can be protecting them from wave and tidal action, where the cable enters the wind turbine or the offshore substation, J-tubes, and substructure interfacing. Dynamic cables come with new considerations, including designs for cable interfacing, your buoyancy modules, which are new for dynamic systems, new configurations and topology designs. Some of these topologies are optimized to improve O&M. These will include connectors that could either be at the substructure or on the seabed. They could be two-way connectors or they could be subsea hubs. It also sees the introduction of multiple armored layers on your cable, as well as dynamically treated cores. Next slide, please, Phil. So now we'll move on to some of the challenges that we've seen through risks. So there are a number of risks that affect static cable. These include a high number of termination and jointing failures. Cable protection systems and fibre optic unit failure modes have led to multiple large-scale repairs in the past, as we can see in some 4C data, as well as we know in the public eye on the cable protection issues that we had a few years ago. Third-party damages from anchors and trawling lines, environmental damages such as seabed mobility, making the cable vulnerable. Outer sheaths can also be damaged through fatigue, degradation, and cracked propagation. And partial discharge can affect the cable from fatigue and aging of the insulation or screen, and water ingress contamination, and of course abrasion. There are no representative failure rates for static intra-array cables specifically. Two perhaps most used in literature would be Warnock, from 2019, that stated that 0.003 failures per kilometre per year was the failure rate for cables. This, however, focuses on export cables for the UK alone. When we look to perhaps a much better known and well recognised document, we have SIGRA Technical Brochure 375, which states 7 times 10 to the minus 4 failures per kilometre per year. However, what we have to realise with this SIGRA brochure is there was very limited information on offshore wind cables within the survey, so having that as a representation of intra-array cables is difficult to justify. Next slide, please, Phil. So when we move to dynamic cables, we introduce a number of new risks. But what we have to realise as well is that the risks to static cables are still very much within the mix. So the risks potentially damaging to dynamic cables specifically have been highlighted to us as the cyclic loading on a cable can lead to fatigue across all layers of the cable, specifically metallic fatigue on the screen wires. High dynamic bending can cause issue at the hog and sag bend of your dynamic configuration as well. Seabed bending and wear can also be an issue, along with the abrasion. And minimum bend radius can be surpassed as an issue during operation, as well as through installation, that is more commonly seen for static, but is also seen for dynamic cables. We also have to be aware that from oil and gas, there are failures around bend stiffener connectors as well. And we have the risk of marine growth when we're looking at shallower waters than oil and gas, which for pipelines, marine growth is still an issue. But when there's a lot of light having access to your cable at its configuration, there's potential for a lot of marine growth, which can increase the diameter of your cable and also cause a lot of extra weight to your dynamic cable as well. The CoreWind D4.2 report, released in 2023, states that dynamic cable failures will be 0.025 failures per kilometre per year. This is significantly higher than what we saw for static subsea cable rates, but what we have to also remember is that those failure rates probably weren't as representative as we would like. So we still aren't too sure what those failure rates are for static inter-array cable. So when we look at all of this, we need to realise that O&M protocols must be heightened for dynamic cable systems, with a requirement there as well to introduce monitoring systems. We can look at monitoring systems from other sectors, such as oil and gas, and we can also look at case studies from fixed wind sites as well, where a lot of fixed wind sites are introducing new monitoring technologies. But we should be looking at monitoring across your electrical aspects of your cable, mechanical, acoustic for any sort of third-party damages, and thermal monitoring as well. Next slide, please, Phil. So this lists here some use cases for different monitoring and where potentially you could use condition monitoring. And this list is extensive, and this is just to show you the amount of options that are out there. But if we look to, first of all, the motion on the top end of your cable connected to the platform, we could potentially be looking at acoustic beacons or DGPS or MRU technology. If we want to monitor wave and wind activity to better understand the movement on the cable and the substructure, we could look at wave buoys, radar, ADCPs, as well as forecasting services. Marine growth, we could look at external ROVs or AUV inspection, sub-CCTV cameras, infrared or depth sensors. If we want to understand the temperature hotspots through our cable, we can use DTS, which is distributed temperature sensing, which is a very well recognised and well-established technology used for fixed wind. We could also look at termination temperature sensing as well. If we want to understand cable curvature, we can look to internal fibre optic strain monitoring, which is your distributed strain monitoring. You could also potentially look to online line impedance resonance analysis, also known as LIRA. If you're looking at your bend stiffener angle and motion, you could look to strain monitoring again, but more sort of external strain monitoring. Buoyancy module coordinates, you can either look at cable motion monitoring or cable angle monitoring as well. Tension and compression, there's hydrophones, depth gauges. Seabed mobility, you could be looking at acoustic sensing. Power quality, distributed electrical sensing. Partial discharge, you could be looking at, again, well-established online partial discharge and DTS. You could be looking at acoustic sensing. And mechanical impacts, where a number of these different technologies could support to understand various different local mechanical impacts. Now, that is an extensive list of different technologies, so there's lots to choose from. There are so many options that we need to be able to understand what are the main concerns and main failure modes on our cables, how often are they going to occur, and which ones are the best ones to be able to detect earlier and deal with on a lower cost than what we're currently seeing in catastrophic failures. Next slide, please, Bill. So just a quick overview of O&M and what's expected. So during operation, the dynamic cable system's health must be maintained to ensure that the cable is in good quality and that it's going to last its full expected lifetime. So there are a number of different tasks that will be undertaken. So there would be system maintenance services on a regular basis. You would have preventative maintenance, where this can be done through having a sort of heightened inspection of your cable, understanding if something is deteriorating, when to fix it, fixing it during your low peak times. You could use condition monitoring for that, or just a heightened inspection. Documentation and reporting. It's always key to keep notes of different things that can occur to your cable, keeping benchmarking within your organisation, and upkeep and storage of spares. So understanding the frequency of failures, what components are likely to fail within your cable system, and having the spares there and ready. And of course, response and repair. So being able to optimize your repair strategy, being prepared to be able to repair your cable in good time. Next slide, please, Bill. So as mentioned earlier, we are focusing on 66 kV at the moment, but there is an introduction of qualifying 132 kV. There are some standards that can be used for 132 kV electrical power cable, and there's also standards for dynamic cables and a lot as well that we can take from oil and gas. But there are still many challenges facing the standard specifically for 132 kV dynamic cables and having the relevant standards there to meet the needs of the industry. Some considerations to 132 kV I've listed on the screen for you here. Some of them are positive, some of them are areas for us to develop on. But there's an increase in insulation when we're dealing with higher voltage cable, and that's to handle the higher electrical stresses. So the cable will be bigger. For 132 kV, to reach qualification, as I've mentioned already, it needs to meet all the standards, and this is across design, materials, and testing. And we need relevant standards tailored to the expectations of 132 kV dynamic cable. On a more optimistic note, if we move to 132 kV, we can reduce losses when moving to longer cables. So if we're looking to floating offshore wind sites but having a fixed substation, we may have longer feeder cables to the substation, and 132 kV would be a benefit in that scenario. Substations and turbine transformer and equipment must be able to accommodate the increased voltage and potentially complexity, which may lead to increased project cost for supply, upkeep, and training. Also, the increase in connector size for 132 kV. We will also have a challenge when looking to the supply chain and installation services, when potentially we might need new equipment able to accommodate larger cable due to larger insulation. And there's limited industry experience for 132 kV dynamic cable. So this could lead to uncertainties, but uncertainties that can be outweighed through appropriate planning and clear understanding of technical and economic implications. So that does seem a little bit negative, but this is a presentation to highlight challenges and barriers. There's a lot of opportunity to moving to 132 kV, and when we're looking to higher capacity turbines, we will need to start adjusting to higher voltage levels of our cables. With careful planning and upkeep in corresponding standards, there's a lot of potential to 132 kV. This includes allowing critical consideration of expansion, as I've mentioned, looking to higher capacity turbines. Another benefit is if we tackle this earlier on, we're able to support the supply chain in supply chain readiness and mitigating against these bottlenecks at an early stage, such as standards and available equipment, and pushing through these technical barriers. So if you jump to the next slide, please, Phil. So just a couple more slides from me, and I will be quick because I realise I'm running over my time. But to support the industry in the move towards large-scale floating wind and new technology development in dynamic cables, the Floating Offshore Wind Centre of Excellence, with 18 floating offshore wind developer partners, has introduced the Dynamic Cable Strategic Programme. So the aim of the strategic programme is to improve the floating offshore wind industry's access to suitable, reliable and cost-effective dynamic cable technologies, including some of our key project focus areas, which are topology reviews and connector types, deep water design, installation methods, risk and mitigation, condition monitoring and integrity management, supply chain capability, both in the UK and globally, and floating and subsea substations. Next slide, please, Phil. So with that in mind, if we bring it back to the Celtic Sea and the opportunities in the Celtic Sea, in October 2023, as you know, the Crown Estate outlined 3 project development areas with an overall capacity of up to 4.5 gigawatts under the Future Framework. There is a lot of potential for different novel transmission solutions. By considering the scale of these projects, there is also potential for including 132 kV inter-array designs in the future. Bringing it back to 66 kV, there is also potential to support new floating offshore wind topology designs and 66 kV connectors, with potential to minimise O&M costs by reducing the complexity for your process of tow to port, which will absolutely be likely for cases for the near future floating offshore wind sites. Also, by moving to large-scale floating offshore wind farms, the integrity of dynamic cables must be considered with thorough integrity management regimes in place, focusing on mechanical stresses throughout the cable and also the cable taxonomy as well. So that's all from me. I hope that you found that informative, and I'm happy to take any of your questions along with my colleague Bradley. Thank you.
Perfect.
Brilliant. Thanks, Charlotte. Perhaps just
Do you
leave
have
that Celtic
slides, Brad,
Sea
or-
image on. No, there's no slides from me. So if you want to just leave the Celtic Sea on.
Yeah, there we go.
The
Great, I'll leave you to it.
No, the Celtic Sea image that I think we had from.
Oh, sorry.
Yeah, it's
Just
This
my
one.
last, yeah,
Yeah.
there we go.
yeah, that
Yeah,
one there.
perfect. Yeah.
Yeah, thanks very much. I don't see that there's any questions in the chat. So Charlotte and myself will open some questions and sort of just bring them across through the audience and just see if if there's anybody else that wants to contribute and open up that sort of discussion. I'm really interested, with my work in the Centre of Excellence and how we formulate, resource and understanding what the Celtic Sea has in resource and using LiDAR and also reanalysis data. Python has become, a big avenue for a lot of us to start tackling. That image that you can see on the screen has been generated by Python. So it's understanding, a lot of these areas. So Charlotte, I want to just sort of delve down a little bit more in the 132 versus 66 kV. And I think, all the discussions that we've been having with various supply chains and with and so many different pathways under the Centre of Excellence. How do we feel that we can sort of contribute and give confidence to the to create this environment of that 132? Do we feel that there's a readiness that's there? Do we feel that we've got this progression from 66 kV first and then just prove that that's workable? And then as these turbines go, we've got 15, 16, 17 megawatt turbines to look at. Do we think that there might be a sweet spot with this 132 kV?
Yeah, so I have heard some mixed reviews from industry about 132 kV, but I think the truth is that we are moving towards qualifying 132 kV cables. So when we look to larger capacity turbines, we need to start thinking about upping our collector grids to a higher voltage. There are, as I've mentioned, challenges facing 132 kV. But if we look back to when we were at 33 kV wind farms, I'm pretty sure a lot of my first conversations when I started in the industry was that 66 kV wasn't possible and it wasn't going to happen. So I think when we as an industry decide to move forward with something, we will succeed. We need to make sure, however, that before we kick off with 132 kV, we have the correct standards in place and we're supporting the supply chain through having the right equipment there to manufacture larger insulation diameters and being able to ensure that the right vessels are there if the vessels need to change at all, which they might not. So there's a lot of things that we need to understand as an industry to support the supply chain in producing the 132 kV.
Yeah, excellent. Phil, you got any comments you want to make on that one?
Not from me. No, I
Nope.
defer to you guys.
There's some in the chat, I believe.
Yeah, I'm just going to open those up. We've got a few questions in the chat. We've got one. Is there potential for new commercial model to delivering array cables?
Sorry, say that again. Potentially.
Is there more potential for new commercial model to delivering array cables? I'm not too sure if I understand that. Who put that question in there? Has anybody put that question in there?
That's it. I mean, I'd be open to answers from the floor, really, from the people, from the private sector can take it on. But it came out of some of our risk workshops and looking at the failure rate, I think, as a result of previously, and how the insurability of these systems. So, is there a way to essentially take on the risk? So, that it's a kind of a thought provoker at this point. Is that the technical challenges remain, the challenge on monitoring and bringing the breakage rate down, but actually, is there a new commercial model here that has got potential offshore wind that essentially buys the risk of the developer? Yeah,
so no, that's a good question. Yeah, so insurance is a tricky one because when you're looking to float in offshore wind, there's a lot of risks involved. There's a lot of questions within the industry just now for offshore wind in general. How can we readapt the model of insurance so that it becomes less of a challenge, and the market will soften, because at the moment the insurance market is hardened, and that's due to high risk failures on both fixed and floating, well, mainly fixed sites, as we have mainly fixed sites at the moment. But we will probably see that the risk will continue to rise when we look to new technologies like dynamic cables for large scale farms. So my kind of answer to that question, although not being perhaps too into that subject for floating offshore wind, I would say that there needs to be a better way to profile your cable's performance. So if you are able to have the right condition monitoring systems, it's not so much that if you have a condition monitoring system, then you're obliged to fix the problem that you spot earlier on, which is kind of how it sits at the moment. But the way in which it should sit is if you use a condition monitoring system to identify that you have a reliable system, that you're looking after it, that you aren't pushing it past its limits, then you should be able to get cheaper insurance. That would be to me an ideal model. But of course, that's not how it works. But potentially, that's one of the routes that we could go down to ensuring to ensuring that insurance is more of a feasible option for this type of technology. You can see it across when you look at wave and tidal insurance as well. It's really trying to take what we do for offshore wind and fit it across different types of marine energy systems, but the risks are different. So we need to start looking at each kind of project that we work on and looking at it as an individually tailored plan with the insurer.
That's really interesting. Thank you.
Yeah, we've got another question from Timothy. What's the lead time for an order of cable, or how does the system work? So Timothy, I can answer that just sort of partially, and then I'll put it up to my other colleagues. The lead time, when we start to talk with various manufacturers, there sort of becomes this almost a bottleneck between the developers and the manufacturers. And what starts to happen is, you know, a lot of them are ready, but it's about what do we need? So we've got to create that environment in what cable do we need? What voltage do we need? You know, a big discussion has come up in wet mate connectors, you know, over time. We've got hundreds of, you know, wet mate connectors that have been put in through oil and gas, but it's about what do those look like for the future of floating offshore wind. And I think that's where that lead time will happen. So when Charlotte was talking about standardization, it's really important that I think we start sort of tackling that, because I think those lead times will then start to be affected. And that delay then starts to then, you know, incorporate that, you know, that process as you're wanting to, you know, to have the cable size, you want to have, you know, various voltages, you want to have different components. It'll be like a group of Lego pieces coming together, but they all have to be of the correct, you know, structure to be able to do that. And if you feel anything else on that, Charlotte?
No, I think that was a good answer.
Yeah.
I think the UK is in a good position. You know, we have Sumitomo up the Highlands, we have JDR, we have Technip, Oceaneering, all these different cable suppliers within the UK. We're pretty strong, I think, in terms of supply chain, but we need to make sure that we don't have those bottlenecks. So if there's an increase, and this is a challenge, is when we look to our floating offshore wind, we require different components than we would require for a fixed wind, such as buoyancy modules or dynamic cable, which is very similar in some cases to umbilicals. So we've started to see umbilical manufacturers move into floating wind rather than fixed. But what we need to be careful of is at the moment, our floating wind is demonstrators and small sites. So when we start with this influx in large scale farms, we need to really make sure that we're supporting the supply chain and being able to keep up with the demand. And I think that is one of those challenges that the industry needs to address as a whole.
Absolutely. There's another question from Simon. Will the increased insulation requirements of 132, does this drive up the typical minimum bending radius? So this is from Simon. Simon, I've been doing quite a lot of work with over the last probably 6 months in losses. And we're trying to work with ABB and SIGRA and trying to sort of understand what the cables are doing as far as sizing goes, so the cross-sectional areas. So we've been looking at between 300 and 2,000 millimeters squared. And by means of those cables, those bending ratios will certainly change because of the thickness of the cable. So if it's going into a J tube or going into a subsea hub of some sort, that's going to change. And if you've got a lazy wave, as those, will start to then shape. But I think the big thing that really came out for me was that was these losses. And we've got 4 fundamental, huge, big losses that occur in alternating current. And those losses became, your core loss, your screen loss, your dielectric, and your armor losses. And modeling that over a 20-kilometer period, so if we put a string together, we started to see roughly about 0.9, of a 0.9 of a gig, relation to losses that were starting to be, within this AC system. So I think that's going to affect it substantially. But I think the 132, because of the current carrying capacity, we're going to be able to up that to suit the 15 megawatt turbine. I think that's going to really start to see compared to a 33 or 66. So it's like Charlotte was saying in the presentation, I think it's so important that we start to get that standardization in the correct line. And we start to do that work now. Otherwise, I think those risks and reliabilities are going to be an issue. We're going to then see this because we started to go into these developer discussions, and all of a sudden, people started to bring up this losses, and that's where we, started talking with SIGRA, and they've just brought out a new document to then highlight a lot of those areas that we're starting to talk about. So fingers crossed that hopefully that sort of answers that question that you've asked, and a little bit more within those losses that we're looking at. If anybody else wants to comment on that.
No, I thought that was an excellent answer. Yeah.
All right, so I can't see any other questions in there. So I'm going to just have a quick, gander and have a look and just think if we can bring up perhaps 1 or 2 more things. I know that we've got about 5 minutes left. If there are questions and you feel you want to reach out to either Charlotte, myself, or Phil, please do through our Catapult, avenue. We'll be able to then, perhaps have discussions with you. We've got the, Celtic Sea Developers Alliance that's been generated. A lot of our reports from the Cornwall Flow Accelerator are on the Celtic Sea cluster. So I did a lot of reports on the Southwest Transmission, wet-mate connectors, the hydrogen, and also what we're going to do with subsea substations or floating substations, which is now going to take another avenue as we start to move forward. So if there are any discussions around those on the electrical infrastructure going all the way from turbine to grid, how are we going to fit in with the Celtic Sea, how are we going to deal with the Crown Estate and the allocated 4.5 gigawatt that they've allocated, these PDAs, and also how's that linkage going to be? I know that the H&D have done a follow-up exercise, so we in close discussions with the National Grid so that we can try and start to shape how that topology is going to look. Within some of our reports, we've looked at how topology suits a 132 and how the different geometries will look. So there might be some discussions, around that might be able to suit some of the audience that are here today. Because it's all about us generating that supply chain, how we're going to build that, and how we're going to scale it. Phil mentioned that earlier. It's all about the scalability and how possible is that going to be able to scale this to where we're going to need it. If we're only talking about that 4.5 gig for now, there's that extra 20 gig that we have to look at, in the refined areas of search, which is C, D, and E. So what we're doing is modeling that entire region and having a look at what that wind resource looks like, so that we can get it right. We can understand what climate change is doing, because a lot of these turbines will eventually, you know, hit 26 meters per second, and they have to be feathered. So we need to look at that meta-ocean data and see how that all falls in. So the emphasis is around capacity. It's around a positive impact to the region, and how does our expertise at Catapult start to filter in and through the CFC and Celtic Sea Power, and all of us as partners start to feed into this you know, this process. So I hope that sort of answered those questions. I'll just keep checking the
there's
the chat.
Couple more questions. We have Scott Davey, who's asked.
Hello, Scott. Yeah, nice to hear from you again.
As turbine ratings increase beyond 50 megawatts, do the benefits in terms of performance / costs of 132 kV become clearer? Would fixing turbine ratings at 15 megawatts stunt the development of 132 kV? Great question, and I think it's one that it's tricky to answer. I think 132 kV provides a number of different benefits. So you can look at the better efficiency of moving to a higher voltage. You could also look at the potential to, if depending on what your site looks like, if you're wanting 10, 15 megawatt turbines on a string, if you're wanting to look at a particular amount of branching or redundancy, you may want to have 132 kV to be able to fit a higher capacity on one string. It depends on a number of different factors. I don't know if that was a reasonable answer, Scott.
Yes, Charlotte, thanks. Hi. Yeah, no, that makes sense. I know there's lots of different variables that affect it, but yeah, I guess if they're fixing, or a lot of talk about standardizing turbine sizes, then you need to kind of tie in your development of the cable with that. So no, that makes perfect sense. Thanks.
No, it's a great question. Do you know if operators are planning or developers are planning on sticking to 15 megawatt? Is this something that you've heard?
Not particularly. It could be an option, but no, it's not. I certainly think that the turbine suppliers are pushing on with beyond 15. Obviously, it depends on the timeline of your project as well as to which turbine you might want to go with. So okay. No, but I just kind of thought 15 is kind of a cut off for where you might be wanting to look at bigger cables and so on, depending on your string sizes. So no, your answer made perfect sense. Thanks.
Thanks, Scott.
I could pick up on that. I think it's a really sharp question, actually. I think that, you know, there remain, you know, we obviously these, you know, Brad and Charlie are fantastic. You know, it's really, really deeply expert. The challenge is not this. Some of the things we still don't know. There are some the detail as a danger. Detail gets baked in as an assumption. 15 megawatts. You know, it's we're trying to foresee this stuff is really challenging. So it does open the possibility, if there's that first mover challenge, can become an opportunity. Can that solution be defined at scale in advance? Because otherwise, we seem to, the worry is these challenges probably sort of circle around each other, and there's no sort of first mover that really starts to define it. In which case, you know, all the cards sort of begin to slot together, or whatever the analogy is. So that I think that's at the heart of what we're trying to do here is to build a capacity to do this. Some things need to get defined, and we can't necessarily look to developers for various reasons to define that in the early stages. Maybe it's going to come from capable supply chain companies.
Yeah, no, that's great.
There's one more question from Richard. I think we're about to fit in one more, Charlotte.
Yeah.
Are you in contact with, aware of any manufacturers actively looking at screen wire, water barrier dynamic fatigue, or on our test rig in Aberdeen?
So I can answer that very quickly and say we can't tell you if we do or not on our rig.
I suspected that might be the answer, but thank you.
Yeah.
But in terms of manufacturers looking into that, I have had discussions with some, yes.
Okay, I think just to like frame the question more, it's that in terms of a supply chain for cables, you can build out that in whatever way you want to, but do we have the technology behind the cable design where once there is a supply chain, are we building the cables that will actually perform the required function and not fail by fatigue within 5 years, say? So yeah, not so much can the supply chain be built, but yeah, once the supply chain is in place, can it build a suitable product?
Yeah, no, it's a great question, and I think that's one of those questions that I think if I could answer, then I'd be a millionaire. It's such a huge problem, and I think one of the big things to think about as well, and I think we've all heard it at conferences multiple times, is we shouldn't be looking at floating wind as just an adapted version of fixed. It should be a completely different system, and that means, you know, readdressing how do we layer up our cables? You know, how do we protect our cables? Why do we want to add additional armored wire layers when we want the cable to be able to be bendier? So that there's different solutions that we should potentially be looking at, instead of just going with what was initially an underground cable to then being a subsea static cable, to then making slight amendments to make it into a dynamic cable. There's a lot of opportunities there to readdress maybe some of the issues that we face already. So I don't know what the future is going to hold in terms of that, but we need to have, like you say, standards in place. We need to have appropriate testing, research and development, and I think there needs to be better collaboration as well, which is tricky when I think manufacturers are all looking to new solutions and new designs internally. So it is difficult to know where the industry sits at the moment. I hope that answered your question. I realised I went off and one there.
No, I couldn't agree more in terms of what it's like, especially with 132 kV. That's what most of the fixed export cables are at the moment. They've all got lead sheaths in them, and when you read the papers about lead sheath fatigue, it talks about tidal cycles being a problem, which is 2 reversals a day. And if you're going to stick that on a floating wind turbine, which has got thousands of reversals a day, your cable fails almost immediately. So there needs to be a change in the design for that.
Yeah.
I also think, Richard, that there's in situ that's going to be needed. We're going to need to see that. You know, I know that, you know, who's going to take that ownership, and as failures happen, you know, I think that's when we'll see what will, you know, how we can learn from it. But I think it also collaboratively, we need to all share that knowledge. You know, if a failure has happened, I think, you know, the industry needs to know that that's happened, and I think that will really benefit moving forward.
Yeah, I think everybody within the industry shares that, but nobody's willing to actually share the data.
That's the thing.
Yeah, no, thanks very much.
Brilliant.
Do we have any other questions there? Oh no, you've answered that one already from Jonathan.
Cool. If you want to put our emails into the chat, you know, we're more than welcome to take any. I don't know, Charlotte, if you're happy, but you can certainly put mine in.
Of course.
So if there's any discussions that are needed, please, you know,
I'll
email
do
us
it in
directly.
a follow-up email. Yeah, no, that's brilliant. That's great. I think this the whole, you know, it's great that the whole point is to generate questions and solutions. So yeah, we'll follow up. We'll send the slides around as well, and it's great that you're able to answer questions. So yeah, hopefully this is the start of something, and it will build to providing solutions from the UK.
If anybody,
thank you, Bradley.
Sorry,
thank you,
Phil.
Charlotte. That was fabulous.
Thank you. I was going to say as well, if anybody's interested in the Floating Offshore Wind Centre of Excellence programme, please do drop me an email. Like Bradley says, I'll put my email in the chat. And also if you're interested in any of our testing facilities as well.
I think Darren's got his hand up. Do you want me to?
Oh, go on. Well, I mean, I'm here all day. Go on, Darren.
Good stuff.
I'll
good
hang
stuff.
Thanks all if you're dropping off. Really good.
Yeah, thanks very much, everybody.
No, I just wanted to say, kind of from sitting from the other side of the fence, from a kind of cable supplier, it's been a really good, interesting session. I suppose one of the points from the manufacturing side is trying to achieve that reliability and the time that it takes to obviously do the analysis, do your screening, doing your research and development, testing, qualification. And I think from the manufacturer standpoint, I suppose our biggest challenge is, where is that fixed point? Is it going to be 15 megawatt turbines? What types of structures is it going to be? Is it going to be steel, concrete? What's the floaters? Because all this has an impact on the actual cable design itself. So from a cable standpoint, that is where I suppose we're finding the biggest challenge. So what we're having to do is kind of put our flag in the sand and go with what we feel is going to be that kind of point where the industry either catches up or not catches up, but just gets to that stage of being comfortable. So, but again, forums like these and discussions and talking with all the other OEMs, because Bradley and Charlie, you made the other point as well, that the cable side of things probably only going to be not even in 5 5% of the actual project itself. Other aspects are going to be like, say, your buoyancies, your connectors.
Yeah.
How do you install? What's the OEM? So if you can design your cable, which kind of takes all those points into consideration, that's the thing that probably takes the longest amount of time. Not necessarily manufacturing the cable once you've got there, but I think we just need some of the project scopes to get further down in terms of definition, which allows us to kind of base our analysis and work on those aspects. But yeah, absolutely fantastic session this.
Thank you. That's really
Yeah,
useful,
good,
Darren. Thanks.
thank you.
I really love that point, Darren. Thank you. I think I said it, mentioned it before, but it's for me, it's really important from a regional development point of view, because what you're saying there is that we, there's moving parts here, and the foundations, it's still all those moving parts. None of them are settling. When one settles, the others hopefully will start to fall into place. And what we can see, and happy to be corrected, it'll be the first one that can genuinely be deliverable at scale, and then the other things will start to fall into place. It'll have to be rapid. So again, from the economic development point of view, once we've got that moving, we can start. It might be that the jewellery on inter-array cables is a very significant part of Cornwall GVA. So but we can't get to there from A to B without a long process of moving parts kind of coming together.
Yeah, definitely. And I think the challenge that cable manufacturers are potentially looking at, it'll be the same for the people who are responsible for the mooring lines and suction anchors and all that good stuff. But as you say, like, we're not going to get there and get those numbers and get those projects in the water unless we're collaborating. So looking forward to some more of these sessions.
Great.
Thanks, Darren. Yeah, I think it'd be so nice that we get everybody, that's in the north that's learned lessons, and we bring that to the Celtic Sea as well, and it goes across, and that's where we sort of want to create that avenue between, Charlotte and myself, to create that sort of avenue.
Absolutely.
Okay, I'm happy to wrap it up. I think we've got a few people still on the line, maybe falling asleep, I'm not sure. But yeah, you guys are great, really brilliant. Absolutely. Yeah, that was fun. Great. Slightly slicker than last time, but that's probably not a bad thing.
Good.
At least slightly.
Yeah, thanks for everything. Thanks very much, Julia.
Thank you.
No, thank you.
Thank you.
Great. All right.
Thanks, everyone.
Have a good day. Bye.
Thanks, Bradley. Thanks, Julie.
Bye.